Hello, can you hear me good? All right, so welcome to Ignite. I hope you're all having a great time. Feels like being a rock event in technology, I guess. Are we good to go? Are you having a good time? Can we do this again? Are you having an awesome time? There you go. That's the audience that I want to hear about. So my name is Vijay Chandanar, and I'm here with my colleague Jonathan Tuliani. Jonathan, you want to wave your hands? So we are from Azure Networking, and customers have helped us to build great products, by feedback and honest suggestions. So we are happy to have one among them today, Sigfus from Mine and My. Sigfus, there you go. So Sigfus is going to talk about his experience working with the Azure Cloud Platform, and more specifically on his experience integrating with the new service that we are going to be announcing, or actually have announced. So without further ado, let's talk about the agenda for today. We want to set the context in terms of what we are going to deal with in today's talk. We also want to talk about the overview of the various DNS services that we have in Azure today. We also want to introduce the new kid in the block, and Jonathan is going to do some really good DNS deep dives. Right, Jonathan? There you go. He's all set for it. And we're going to have some awesome demos. So without further ado, what is DNS and why DNS? So the closest analogy for DNS is a yellow page, right? You want a service, you want to access that service. You go to a yellow page, you sift the pages around, look for the number that you want. So you want Joe the plumber, you look for Joe the plumber in yellow pages and get the number. So it is a translation from a name to a number. So the domain name service or system is essentially a distributed hierarchical naming system that was introduced by a computer scientist by name Paul Markopitis. Have you heard of Paul? All right, awesome. So was the vision of Paul that a protocol that was defined 4 decades back. It's really profound to even think about it. A protocol that was defined 4 decades back is still finding its use today, and it's evolving. What started off as a protocol for enabling computers to talk to each other in a LAN has evolved, has withstood the tides of time and transitions in technology. Today you have mobile apps talking to mobile backend. You have gaming consoles talking to game servers in the cloud, and these are really low latency applications. You also have media headends talking to media clients and vice versa. And more recently, you have a plethora of devices in billions in the realm of Internet of Things that are going to be using DNS. So DNS has found its application in a very ubiquitous and pervasive fashion. So it is very important. But why is it so important to you? Why is DNS important to you? There is a lot of empirical evidence that suggests and indicate that customer satisfaction is closely tied to the responsive of an application. The website load time is a very key indicator of how your revenue dollars are going to look like. And there are excellent correlations on this. Amazon has done some good studies, Google has done some good studies, and so has Bing. And an interesting insight I got from one of the websites called httparchive.org is that an average web page does 17 DNS lookups. Now, if you go with a bad provider, even 100 millisecond latency per lookup is going to translate to 1.7 seconds of page load time. So imagine you pick up your mobile phone and you open a web page and it's going to take 1.7 seconds only to do the DNS lookup. Forget about content downloading. So in today's millennial generation, which is so used to instant gratification, that's not a workable scenario. You're not going to succeed. So you need to really work with a provider who can really give you good performance. Let's look at an example here. So you have content. This is a real life situation, by the way. I just snapped it from the web. On the left, you have a provider that's going with a server X, right? He's got about 6.9% DNS time spent in just lookups. That's quite profound. And on the right, you have about 28% of the time spent in DNS lookups. That's why it's critical. Slow load times are going to drive away your users. It's going to drive very low dissatisfaction. You don't want that. You want to go with a provider who can give you a really good performance in tens of milliseconds of latency. Why is the intersect of Azure important here? Why Azure? Why not anybody else? We talked about performance in tens of milliseconds of latency. We'll talk about that again. But how about hyperscale? Just to give you a flavor of hyperscale, Azure stores about 50 trillion objects in its storage. We have about 5.1 million transactions every month. Just the cable fiber infrastructure in North America, this is very profound again, is enough to go around the globe 4 times. That's quite significant. So you want to work with a provider where you can scale your applications and scale your workloads as you want it to be it predictable, be it unpredictable. So it's extremely important to work with a provider who can help you expand your workloads. How about security? There was a very interesting study from Akamai I read last year. It talked about the increase in DDoS, 90% from Q3 of 2013 to Q4 of 2014. That's 90%. And DNS is a favorite protocol to be attacked. You have something called reflection attacks in DNS that are very common today. Now you have to choose your providers very carefully. Do you want to go with a provider who can handle the scale across 19 regions in the globe, or do you want to handle with somebody who cannot handle it? So you need to make your choices. It's very critical that you make your right choices. And availability, again, translates to the fact that we've got huge deployment of compute regions across the globe. As I said, 19 regions. That's equivalent to Google and Amazon put together. And you have tons of virtual machines running all over the place. So you want to go with a provider who can really help you out, expand on your business. So let's look at some of the DNS services that we offer currently. In Azure, we have 2 categories or buckets. You have what you call as internal services, and you have customer-facing services. So across these 19 regions, we have data centers, multiple data centers, and each data center typically has multiple clusters of rack, and each of these racks are loaded with a fleet of recursive resolvers. So we have hundreds of recursive resolvers spread across 19 regions in the globe today. We do billions of operations on a constant basis. We also have what you call as an internal DNS service. So when you have a virtual network defined in Azure and you have compute instances, you have virtual machines, you have cloud services that are all deployed, and they need to talk to each other. So you need a domain name service for that as well. So we have this internal DNS service that provides that. We also have what you call as, this is something very recently announced, public IP. Earlier we offered this feature, you could have a VM and you could have a public IP, but guess what? You had to work with an IP address, 192.168.1.3. Now how sucky is that, right? So we fixed that. Now we heard you. Thank you for the feedback. We heard you. We fixed that. Now we have domain name services where you could supply the prefix. As an example here, you have web role. That's a prefix provided by the customer. Now we attach a suffix to what we have in our system. Now as you scale, we add the instances like 0 and 1 and 2 very dynamically. You won't even know about it. So we take care of this for you. So this was a recent addition. Let's talk about another service that's very commonly used in Azure. It's called the traffic manager. As the name suggests, it primarily diverts traffic based on some predefined policies. And it enables a fantastic range of applications. Now, you would want to build an application that's high performance. What do I mean by high performance? Let's assume that you're a content provider. Let's assume that you're a Netflix. Now, you want to be able to reach your user from the nearest location, geographical proximity from a latency standpoint. So we enable that workload scenario. How about ensuring that your applications are highly available? Let's say you have a log server application. You want to make sure that all your telemetry is continuously monitored. You want to build an application that never fails. So you could deploy these applications across 2 Azure regions, ensuring that even if one fails, the other one is going to take over. Traffic Manager will take care of you. It will switch to the healthy instance in tens of seconds. You don't want to wait for your pager to ring so that you can go and do a swap of the instance. Traffic Manager will take care of that for you. Now, how about cloud bursting scenarios? You want to test some loads from moving it from on-prem that is exposed to external customers and move it to the cloud. You can always divert a fraction of users to the cloud while retaining your bulk of your applications on on-prem. So it helps you to manage the traffic and how really you can really wield a variety of workload scenarios. And the interesting part is that we are very open in embracing polycloud solutions as well. So it's not that all the endpoints have to be only in Azure. You can also have the endpoints in other cloud providers. So we truly embrace polycloud solutions as well. Does it stop here? No. You could mix all these together and build a hierarchy of policies, what we call as nested policies. So let me give you an example here. At a level 1, you might want to define a policy which says that go to geo A versus geo B. As an example, part of your subscribers can go to, let's say, Japan. The rest of your subscribers can go to, let's say, US. So that's the first level of traffic bifurcation. Let's go one level below. So within US, you want to be able to split them across regions because you want to enable high availability. So you have a workload running in US East, you have a workload running in US West. So even one fails, the other region is ready to take over the load. Now let's take it one step further. Now, even within US East or US West, you want to be able to tie a certain set of subscribers with a unique experience. Let's say you want to flight an application. Here's another thing you can build. You can build additional rules to be able to combine all these things. And it doesn't really stop there. It enables a wide range of other scenarios that are not listed here. As an example, conditional access. You might be in North Korea and you don't want to let anybody else snoop into your websites. Well, we'll help you with that. How sweet is that, right? How about content localization? So you have a geographical reach of subscribers and you have localized your content. You have subscribers from China, you have subscribers from Japan, you have subscribers from all over the world. So with Traffic Manager, based on your source IP, I can divert you to a unique service endpoint. It enables that as well. So, what is new? We do have a new kid in the block. We are enabling, based on your constant feedback and advice, a cloud-scale domain hosting service. And you can run your web apps and all your services in Azure alongside hosting your domains. Now, how easy is that? You don't have to go to GoDaddy or GoMommy or whoever it is to manage your domains. You can do it as well in Azure now, today. And we also offer fast query latency. What does it mean? In tens of milliseconds. We'll come to that in a short while, and we'll explain why. We also offer fast updates. Now, there are other cloud providers who boast that you make a domain zone record update, you got to have a stopwatch and keep wondering when is it going to get updated in all the 50-odd locations. Well, we'll take care of that for you. You don't have to worry about that. And we have a very versatile set of APIs, surfaces that you can manage with. We have a RESTful surface, we have PowerShell, we have Azure CLI for the Linux workload users, we have SDKs in Node.js, C#, and Java. And it's not going to stop there. I can assure that. So we talked about a cloud scale. What does it really mean? So we have a global footprint of locations that serve you with DNS. And this region is constantly expanding. Even today, we're talking about adding additional locations. And these locations are just not chosen out of whim. we take a lot of pain to analyze what the traffic patterns are from users, what are the workload patterns, what population centers should we look at to go and deploy to provide the best-in-class end-user experience. These are all based on Anycast networks, and we talked about high availability. So we have rings of Anycast networks. So even if one edge fails, don't bother. We'll take care of that. We have backup rings to take care of the failure scenario. If one ring is under upgrade, don't worry about that. We'll take care of that as well. We have the backup ring available. We also offer data diversity. What does it really mean? Your records are not just hosted in one location. It's spread across so that even if an edge fails, you will be sent to another edge location. So you have a lot of these excellent features available with the Azure DNS. So I want to show you something very interesting that we did as a part of rolling out all these edge sites, and you'll love this. So what you see here is a step function, right? The first step is when we rolled out the first set of edge sites. Now, this is monitored by over 100 monitoring points across the globe. And as we added more edge sites, you can see the performance and latency. It's going down. And we are going to continually improve on this by measuring what the user performance is. So we've got a lot of machine learning stuff going on in the background. We're going to look at queries and volumes of queries, from what region it's coming from, and so on and so forth. Mine this data, and then decide where we want to deploy the next set of edge sites. So with this, I'd like to hand this over to Jonathan, who's going to do some interesting demos and a deeper dive. Thank you again.
Okay, good afternoon, everybody. Can everybody hear me okay? Okay, fantastic. Okay, deep dive. So Azure DNS, key features. There's a certain set of record types that are the most commonly used types, and of course these need to be supported. We support, the record types you see listed there. Some people sometimes ask, why don't you support SPF records? Does anyone here use SPF records? So a few, yes. So SPF records are actually deprecated. They're now covered by TXT records. There was a debate in the DNS standards community around the use of SPF versus TXT. The SPF has always been supported by TXT in parallel, and the latest updates are actually to deprecate SPF. So we're actually supporting it through the TXT records at the moment. Okay, you use it through TXT. Yeah. So that's where this is. So we support the record types that are most commonly used. PTR records are coming soon, so they'll be with us shortly. Vijay talked about the availability. I won't repeat too much there of what Vijay said. Availability and performance is obviously key to a DNS service, and having the capacity as well to cope with high volumes of queries, in particular in attack scenarios. This is where we've been making a heavy investment to be ready for this. One thing to understand is that the performance you get is not just about having more locations. Obviously, additional locations will help, but the overall performance you get, as measured globally, the way Vijay described, is really there's more to it than just the number of locations. It's a lot about just where are those locations and what kind of peering do those locations have with other internet providers, and that's where you get the advantage with Azure DNS of the Microsoft network. Microsoft has very good peering relationships and is in a lot of very strategic peering locations, and those benefits are reflected in the latencies that you see in this service. And lastly, Azure Resource Manager. Are people familiar with Azure Resource Manager? There's a lot of talks here about it, and at Build last week. So Azure Resource Manager is the new framework in Azure that all services in the future will be managed through, and it provides a certain set of common benefits across all services in Azure. And this new service, Azure DNS, is integrated with Azure Resource Manager. Our APIs for managing the surface are Azure Resource Manager APIs. And that means those common platform benefits of Azure Resource Manager are benefits that apply to Azure DNS as well. So this, in terms of the security, how you authenticate to the APIs and manage those, the role-based access control. If time permits, I may say a little more about that later. the tagging of resources, to help them, the manageability side, and template-based deployment, can be useful as well. If you're deploying a DNS record as part of a larger, suite of, services, websites and VMs and so on. So this is, some of the basics of what Azure DNS is offering. In terms of integration, Vijay touched on this. We have this broad suite. We have these tools, PowerShell and the Azure CLI. I'm going to hopefully demonstrate both of those. There's a REST API, and then there's SDKs, a range of SDKs. So we have, a range of integration options there. Today, we don't have an experience in the Azure portal, the new Azure portal. That is coming. That's a work in progress. Hopefully, we'll have that, for people to try, before too long. Something to talk about is concurrency support. If you're using these APIs, there's always a risk with APIs that, maybe I'm making a change and somebody else is making a change at the same time, especially if it's applications, a multi-threaded application, or, there's a lot of these workflows where people used to handle DNS very much as, it's something you don't update very often, and you have a team that handles the DNS, and maybe you send them a ticket, and they get a few tickets a week, and they update DNS records. That's how DNS used to work. But we see a lot of companies who are moving towards offering their software, ISVs who are moving to become cloud software vendors, and they offer their services instead of as a box product that you install on premise. They offer it as a service in the cloud, and a lot of these models, as a new customer signs up, their enrollment experience includes creating a DNS record, and contoso.partners. Fabricam.net or whatever. They make a new DNS record for each customer that signs up. Now, you want your new customer to be able to use your service, their new account in your service, and this is where fast DNS propagation is very important, because if the DNS record isn't available quickly, that customer has to wait. And if you let them jump ahead, their client will cache the negative record that they get. The DNS will fail, and the client will cache that, and then they're locked out until that cache has expired. So that's a terrible experience. It could be 15 minutes or more. So fast provisioning of DNS is very important, and also these concurrency things, where if you have a system that is making DNS changes, you want to make sure that those changes don't collide with each other. And we support eTags for managing the concurrency, and we support very fast propagation. And hopefully, I'll show both of those in the demo. Let's go. Pricing. Azure, as I'm sure you're aware, has, you pay for what you use. There's no upfront costs. You pay for what you use. So applied to DNS, that means that you pay for each DNS zone. Who knows what a DNS zone is? Are people familiar? For those who are not, just think of it as a domain. The distinction is not worth diving into here, but think of it as the domain that you're hosting in the DNS service. And you pay for the DNS queries, per million queries. And you can see, I won't repeat here, you can see the pricing there. This is the preview pricing. The service is in preview. This is the preview pricing, which is, discounted 50%. For the zones, the zone, you can see that rate is per month. If you only have it for partial month, then it is prorated. So, if you only have it for a couple of days, then that, of course, will be much less, maybe in a dev test scenario. And for the queries, you can see there's a price break when you get to 1 billion queries. Now, that would only be for the larger sites that would get 1 billion queries, but there will be some. And it's worth knowing that if you have a range of DNS domains, a range of zones, then we apply the price break across the entire portfolio. We don't do it, for each domain. You don't have to have the individual domain get past 1 billion. We add it all up, and then we apply the price break. So we like to be fair about that. Okay, I'm going to dive into a demo, but before I do, there is a couple of concepts that I need to make sure that you understand. So, zones, record sets, and records. So a DNS zone is it's the container that contains all the records. There's not much to say about that. Think of it as a bucket, and we're going to put records into that bucket. And I think most people know what a DNS record is. There's that thing that you look up and it comes out with an IP address, or if it's a CNAME, it's a mapping to another name or whatever. But a record set. Sometimes when you do a DNS query, you can see the example on the right, www.contoso.com. Sometimes there's actually 2 records with the same name and the same type, but there's 2 IP addresses for that service. Maybe it's running in 2 locations. And that's an example of a record set. A record set is that's 2 records in one record set. And to be in a record set, they have to have the same name and the same type. So they're both A records, and they're both on the same, WW. The name is www. That's the record name within the zone, contoso.com. So that's a record set. And when you think about how we manage the DNS records in Azure DNS, we manage them as record sets. So you'll see me in the demo creating record sets and adding records to record sets, and that's what it's important that we understand that. Okay, so let's go to the demo. Can I get a time check? I can see up here actually. Okay, we're good. Now just give me a second to get this ready. I will have to switch machines and this kind of thing. I'm going to start with PowerShell. And crossing all our fingers and toes. See if the demo gods are smiling at me today. Okay, so we're going to keep this, fairly simple. So, okay, and you can see I've got a little, cheat thing up here, so I can copy and paste from here rather than having to watch me type. So I've executed these 3 commands already. This is kind of, a generic set of things you always do with Azure PowerShell. Just to the first one, add Azure account, that kind of logs me in. And then I told it which of my subscriptions I wanted to use. And then I switched the PowerShell commandlets into Azure Resource Manager mode. There's 2 modes in the commandlets, and I switched into the Azure Resource Manager mode. So they're done already. So what we're going to do next is we're going to create a zone. And you can see here is the commandlet, new Azure DNS zone. And then I'm giving the name of the zone. And in Azure Resource Manager, resources sit within a resource group. So the resource group name here is RG1. So you can see here, and the name of the zone, ps.com, the name of the resource in Azure Resource Manager is the name of the zone. It's the DNS name. So if I just run that, fingers crossed. Yes, there we go. So that has worked. So now, what happened? So the zone has been created in Azure DNS. And when you create a zone in Azure DNS, it comes with 2 record sets that come for free. They kind of get automatically created for you. One is the SOA record, and this is within the DNS standards. This thing called an SOA always lives at the root of every zone, so of every DNS domain. So this thing, the SOA record is there, and it has certain parameters that determine things, some of the caching behavior on the zone and so on. So that is there. The SOA record is created, and also these things called NS records. As Vijay mentioned, DNS is a distributed hierarchy. So if we have a name here, ps.com, how does a DNS query find the Azure DNS name servers for that zone, ps.com? Well, the way they do it is they kind of navigate this hierarchy that starts at the root domain, and then it goes to .com, and then there's .com will then point to Azure DNS's name servers for ps.com. And those pointers are done with these things called NS records. And when you have a domain created like this, those pointers exist at both levels of the zone. The parent zone needs the pointers to the child zone, but the child zone also has a copy. And the child zone ones, these are called authoritative NS records, and those are created for you. So to set up the delegation, which I'm not going to do as part of the demo, to set up the delegation, you would take the name server names and with your registrar, load those into the name server addresses that your registrar, GoDaddy or whoever, they have an interface that lets you specify, where was my zone hosted. You put those name server names in there, and you would be done. So we can look at the name server names if we do this. So this you can see we're going to get the record set. The name is and in DNS speak is the convention for kind of the empty relative name. It's records at the root of the zone, at the apex of the zone. And the record type is NS, and then within the zone that we just created. So let's do this. And there we are. So you can see here the TTL is an hour on those. And here's the E-tag I mentioned. We talked about E-tags for concurrency. We won't look at those now. And here's the actual name server names you can see down here. NS1-09, et cetera, et cetera. One of the things you'll have noticed is that, well, I managed to create a zone there, but what about, do I own ps.com, or does somebody else own it? Did I just break the real owner of ps.com? And the answer is no. You don't need to be the legal owner of a domain name to create a zone with that name. But you do need to be the owner in order to do the delegation that I talked about. So in the same way you could spin up a VM, install a DNS server on it, and go and create Microsoft.com on that VM, it's not going to be the real Microsoft.com unless you have the rights to change the delegation for Microsoft.com, which we do. We own those permissions. So here, that's what happened here. So the real owner would now have the opportunity to go and change the delegation to use these name server addresses that we provide. Okay, let's create a record set. Let's create a record set, and then we can see it resolve. So you can see here, there's 4 lines here. So this is going to create an empty record set, and the name is again @ so it's at the root of the zone, of the apex. Then we're going to add 2 DNS records to that record set. And these add operations, they're offline operations. They're just happening locally within the PowerShell. And when we're done, when our record set is ready, I'm going to do the set, which will then commit those changes. So let's run this block of PowerShell. Okay, so there we go. This is the 2 records being added, and here it's, there we go with those 2. That's done. So the last thing is, well, let's see. We talked about the DNS resolution being quick. So you can see here, this line here will do the name resolution for us. So this is the resolve DNS. This is like NS lookup or dig for this is the PowerShell commandlet for DNS resolutions. This is the name. And here the DNS only means I'm not going to use any local cache. I'm definitely going to hit the name servers. So let's just run that. And there we are. So the name resolution is working. So we talked about name resolution, that we want it to be quick. So let's have a little go at how quick we can do it. So what I'm going to do here is I'm going to do the same thing again. This time the record is going to be called test this time. But before I do, let me see this. Let me see if I can get this to work. Okay, I'm going to move that over there. And I'm going to get another window in parallel, which is here. Okay, so this one here is going to just continually query for that record test.ps.com against the name servers that we talked about. And that's just running away, doing its stuff. And it's querying, you can see there's a delay of 250 milliseconds. So it's querying 4 times a second. And then I'm going to create the record by running this lot. So let's see how quick it is. So it's not done. Okay, now it's done it. Let's see how long this takes to hit it. There we go. That's it. It's done. So you can see that's a global propagation of the new record in a few seconds. So that's where that's something we've worked hard at, and we see as an important feature, especially as we in this kind of cloud-first world. We see that's the old ways of doing DNS with slow propagation they're just not acceptable anymore, and we want this to be quick. Okay, that's enough there. Let's move over to the CLI we use for cross-platform. Let's have a look at that as well. So I'm just going to, this is a Linux VM that is running in one of our US data centers. I've just gone into the VM, and I've done 3 things already. You can see here I did Azure login. It's like those 3 things I did on the PowerShell. I've provided my credentials. I've told it which subscription I'm using, and I've gone into the Azure Resource Manager mode. So you can see there, those things are done. And now what I'm going to do is I'm going to just give you a couple of examples of just to give you a taste of what the commands look like in the Azure CLI. So here, and I've got some examples here, so I can copy and paste rather than you having to watch me type. So Azure Network. So the CLI, it starts with Azure. Azure is kind of the name of the CLI, and then there's a breakdown of commands within that. So Azure, DNS sits within the network set of commands. So Azure Network, DNS Zone, and then you can always put the -- help, and there's help provided within the tool. So you'll see here the different commands for managing DNS zones and records. That will come up. Maybe a little slow. Especially the first time you run it, it tends to be slow. It tends to load the command. Okay, there we go. So you can see the different commands. I won't read all those to you, but you can just give the idea that whenever you're trying to use this, always just use that -- help parameter to work out what are the parameters you need. Now let's go straight ahead. Let's go in there and create the create a zone. So you can see here, I'm creating a zone. So Azure Network DNS zone create. So RG1, that's my resource group, and CLI.com is the name of the zone I'm creating in this case. So off it goes. There we go, done. And let's have a look at those NS records again, just the same idea. So it's going to look up those NS records for me. There we go. So NS1-02 this time it came. And this is something that's important. Is as I said, you can create, a zone without owning it, which means I can create ps.com, and hey, you can also go and create ps.com, and they'll be given different name server names. So it's always important to look at those NS records and see which where your name servers are living. In this case, that zone has the NS, 1-02. These are the name servers here, and this time I'm going to edit the existing record. So if we, in this case here, you can see Azure Network DNS Zone record set, and you can see I'm going to set, which is I'm applying a change. So I'm changing the TTL to 60 seconds on those NS records that we just talked about, and you can see that is done. And let's just have a little look at those NS records to see it. If you noted previously, the default was an hour for the TTL on the NS records. It's very common to change the TTL on the NS records when you're doing delegation changes and so on, in case you need to do rollbacks or the like. So let's have a little look. And there we go, 60 seconds, so that worked. OK, so let's keep going. I want to show you the REST API that we have. All of these tools, and even the portal when it comes, everything sits on top of the REST API. The REST API is kind of the fundamental, the fundamental layer that everything else is sitting on top of. So the REST API is important, so let's have a look at it. For this, I'm going to use this tool, which is, there's a plugin called Postman for the Chrome browser. And I have to say, Postman is fantastic. So, so if we're calling these REST APIs, this is one of the the easiest tools to use. There's other tools, but this is my particular favorite. So you can see here in Azure Resource Manager, in the URI at the top here, you can see all these URIs kind of follow an Azure Resource Manager pattern. So to begin with, you have these, your subscription ID and resource group names and so on. Then you have this, provider, which is, the kind of, the engine within Azure Resource Manager that handles these particular requests. And then, once you've done that, you then say, okay, this is, I can't read it from here. You have the DNS zone. You can see the DNS zone there, and the format is. The format is that you have the provider name, and then DNS zones, and you have the zone name, then you have the type, and you have the record name. So can I see it better on this one? Maybe I can zoom this thing. Let me do that. That might work better. Is that a little better? Okay. So this is a little easier to see now. So let's just go up and have a look at this. There we go, now I can see it here. So Microsoft Network, DNS zone. So ps.com, we're doing it in the zone we created in PowerShell. ps.com is an A record. And the name of the record is REST. So REST dot whatever it would rest.ps.com would be the name of the fully qualified name of the record. And you always provide an API version when you make Azure Resource Manager calls. So here I'm gonna there was a new zone, so this record doesn't exist today. And you can see here there's a authorization token, which is how the REST API manages its credentials. This is obtained from AAD. I got this just before the talk started. It may have expired, in which case I'll have to get a new one. But let's give it a go. So, and here you can see the JSON format of what an A record set looks like. So you can see you have TTL for the record set and the properties of the individual records. In this case, they're A records, so they have an IPv4 address. You notice the name is not here because that's up in the URL. You don't need to specify that again. Let's send this, see if my authentication token has expired. No, it's still good. There we go. So you can see there it's worked, and it's provided this e-tag. So what you saw here, I had a header here, if non-match star. In our e-tag speak, what that means is create a new record, but if the record exists already, don't overwrite it. So if you need, and this works, you can do this on zones or records. I'm showing it here on records, but it works on zones as well. So this is saying, make sure it's new. Don't overwrite if someone else has created this thing already. So if I send it again, which is, we can edit the numbers even. Let's edit those numbers a little. And then if I send it again, because of that if non-match star, we should get there. No, yeah. So yeah, that fails. So that's as expected. What we can also do is, if we take out the header, it will now work, because that means, okay, I don't care about e-tag checks, just do it, overwrite whatever's there. So that will work. And then you can take the e-tag, and I won't do it, but the way this would work is you can specify an if match on this e-tag, and that would say, okay, if I've got the record and I've made some changes and I'm putting it back, if I do the e-tag check, it will make sure that no one else has been modifying that record in parallel. So that means you're safe from these concurrent changes. This is also supported by the PowerShell. In the PowerShell, we have it will include these. When you create a new record or a new zone, it's doing the if non-match star. When you do updates, it's doing the e-tag checks. If you want to override the e-tag checks, you can. So it's it's designed for giving you a very safe way to integrate how you do your changes. And there's a -overwrite parameter on the PowerShell. E-tag checks are not yet in the CLI, but that's coming. With that, I think I'm going to hand over to Sigvard. I'm just going to keep an eye on the time. I think we'll allow some time for questions. Oh, I have a question now.
Just a quick question. Do you support zone transfers from, say, our corporate DNS server? If we wanted to maintain the writable zones there, and just transfer to Azure?
So would that be as a kind of a one-off import, or is that something that you want to do on a continual basis? Continuously. We don't. It is something we're thinking about, so it's a very good question. I'll be interested to chat at the end, perhaps, to understand a little more detail about how you'd like that to work, because that is something that we're looking at, but it's not supported today. What we wanted to do is, to get the product out with, the core feature set, and we're not done. There's a lot of stuff that we'll be building on. You'll see us, launching over time, and that's one of the things that we are interested in. So I'll be interested to talk more. Okay, let's leave this here. I think we've seen the PowerShell, the command line interface, and the REST API. And with that, I'm gonna hand over to Sigfus from one of our partners, Men and Mice, and let me switch back. Okay. Okay, great. Okay, Sigfus. From one of our partners, Men and Mice. They've been part of the private preview program for this service, which has been running over the last few months. And Sigurd will talk to you a little bit today about the experience he's had integrating with our APIs, and about the integration they've done with their DNS management system. And I think hopefully that's something you'll see that's very interesting. Thanks.
Thanks. Yes. Hello. Sigfús Magnusson from Man and Mice. So maybe a couple of people in the audience know about. Do you hear me okay? Okay. Because I don't hear myself. So maybe some of you know what Man and Mice, who we are, what we do. But this is Man and Mice. It's a 25-year-old company from Iceland, and we develop Man and Mice Suite, which is like a DNS, DHCP, and IP address management solution. And it complements your current service and your current way of managing DNS and DHCP and IPs. What that means is that you have your Microsoft DNS servers, your Microsoft DHCP servers, you have Unix bind servers maybe, and other types of DNS servers, and we also support some Unix-based DHCP servers and Cisco DHCP servers, and you put Metamice on top of it, and we don't take ownership of this information on the servers. So you can still go and you can make updates and changes outside of Metamice. You can create a new zone and it will appear in Metamice. You can make a change in a DNS zone, and when you open the zone in Metamice, you would see the change that was made outside of the tool. So it's like a non-authoritative solution for DNS and DHCP. With Metamice, it's a very tight AD integration. You can take your AD groups and users and grant them access to different objects in the tool. So one group might only have access to one zone on one server. Another group might only be able to maybe release DHCP leases in a particular scope. So you can, with Metamice, you can say, here we have a regional admin group. I'm going to grant them access to make changes to their zone, to their IP ranges. They can create new records and so on. So although the Microsoft has been working on Azure DNS for some time now, and the preview has been sort of like out there for maybe a few weeks or months, we only got a chance to participate like a couple of weeks ago. And I started with Metamice roughly 20 years ago, and as a developer, and some 12 years ago I was kicked out of the dev team because I was a lousy programmer. So maybe that's why they asked me to do this implementation to see how easy it was. And to me, Azure also was quite new. So I had no idea what, I knew what Azure was, but not the concept, resource group. And I had problems with signing up my account in Azure. But I decided to do an implementation in Metamice to support Azure DNS through PowerShell. And I wrote that in like a few hours, maybe, like a basic integration. So Metamice being this overlay solution, we're not taking ownership of data on DNS servers. It was quite easy to just get a list of zones from Azure, get the records in Metamice, and also to update the records. And I'm going to show you now what we did, or what I did. And then, so I started with PowerShell, and then went to also do some integration with using JSON through Python, just to see how easy it was. So I would say it is simple. Once you get the idea of how Azure is, the resource groups and these concepts, then programming like against the API is quite simple. Only drawback with my implementation, I would say, is its speed. It's not very fast, and I'm not doing anything in parallel, so everything is done sequential. So I list like if you make bulk changes, like you copy like 20 A records from one zone to another, we go one by one instead of doing it in parallel. And maybe another thing is that these ARM tokens for authentication, which is the last point on the slide, that was something new to me, and I absolutely didn't have time to work on that. But that's something that we are going to work on. So I'm going to switch to a demo now to show you how sort of like Azure DNS might look in an IPAM solution instead of only the PowerShell and things that Jonathan showed us. So here we have Metamice. So when you deploy Metamice, we put you have an application put on a member computer in your domain, and Metamice will see all the DNS servers and DHCP servers and suggest to manage it. And it will take the data from the DNS servers and DHCP servers into its database. So when for example, I have these DNS servers here, if I click on DNS zones, I get a list of zones from all the servers. And the same for DHCP. Once you put once Metamice is allowed to manage your DHCP servers, you get a list of all the DHCP scopes across all the DHCP servers. And we use this data to, in addition to other data, to give you like a better view of the data on your network. We pick from your routers, we pick subnet information. So if I go to IP address ranges here, I have a bunch of subnets, and these come from the DHCP servers, from the routers, and also from AD. So AD sites and services, we read all this, also the subnets from there. So this is all read into the database. We have the DNS zones and all the A records. We read the ARP cache from the routers and also the leases from the DHCP servers. So we have one view of all this data. So if I go into my demo ranges here and open up a range, we can see it's 53% utilized. We see a view like this here. So we see the DNS entries from the DNS servers that we are managing from the zones. We see also when they were last seen on the network and also some other metadata for the records. And you can use this to allocate a new IP or like just by clicking this, find next free IP address. And it comes back with 38. And in this view here, we can assign some custom tags to it and also add a DNS entry to it. For DNS, it's quite easy to manage DNS as well. So if I go into a large zone like this NAAD, it opens up in a spreadsheet-like window. This is a large zone with 3,000 something records. And you can do here like edits. You can add a new record and you can change an IP address or change the name of a record and so on. So with Azure, if I go here, this is Azure DNS. So these records have been created in my resource group. So I created a resource group called my test resource group, and then I added a couple of zones to the group using Minimize. And to me, a resource group is similar to a DNS view. I'm not sure if you're familiar with that term, but with a DNS view, you can have maybe a staging view and also a production view. So in Azure, we'd have two resource groups. One would be staging, and the other would be production. And you would make changes in the staging, and once that has been validated, you can make the same change in production. So here I go in, this is my Azure account here, and I have a zone here, large AREC test. It's not actually pretty large, but if I double click on it and wait a couple of seconds, it's going to open up. And this is using the PowerShell API. So here we have the NS records that Jonathan was talking about, the SOA at the top, and then we have a couple of records here, down here. So if I take one of these records here and change it to like this here, and it should be 126, it should be 26, and do a save, Minimize prompts you and says, okay, you're about to do this change here, you're going to delete this record here and create a new one, and I'm going to do a demo for. Hit OK, and now Minimize will do the update. We will delete the old one and add the new one through the through the PowerShell API. And with Minimize, at least, you get the traceability. You see who was making the change. So I can go now into the history of the zone and get here like the changes I was doing, deleting the record and creating a new one. With Azure, it's with Azure DNS, I think it's for our customers. It's a great opportunity for them because it's like my previous speakers here were talking about, the scalability and reliability of the platform is really critical. I mean, DNS, we have a lot of customers, Minimize, who are managing their own DNS and external DNS. They might not have the expertise to manage a successful DNS platform. You have constant DDoS attacks and amplification attacks, but with Azure, it's there, it's secure, it's really high performance environment. And I think a lot of our customers would love to take all the external DNS and just move it into the cloud and not have to worry about availability. So they can manage it through a tool like our tool or through the portal, but don't have to worry about the other aspects. And managing or migrating the data from your current service to Azure is pretty easy with Minimize. I have here like a Unix server here with 2 zones, or a few zones, and I can select multiple zones here. I can right-click on them and do migrate. And I can select my Azure account. And this is going to be onto this guy here. Let me just remove this guy here. It's, so the JSON guy was in the way. So I'm going to do a demo again here. So I'm going to migrate these 2 zones over to Azure DNS. Okay, so the demo gods are not with me today. That's good. So this was supposed to be the last thing on the demo, but maybe the guys were right in kicking me out of the Dell team. You know, it's, maybe I'm just a lousy programmer. So, but I'm going to try one more time here. Oh. So that ends my my demo here. Thanks.
Okay, well, I'm wrap up. Thank you, Cephas. The demo gods, yeah. So, but I think people get the idea. You know, this idea that with tools like this, you know, the migrations can be very easy. You know, if you don't want to run these authoritative DNS servers anymore, tools like this can allow you to simply do a migration. You say, okay, migrate the data, move it over. You know, and there's, it's a compelling story, I think, for running things in the cloud. As I see, you know, there's a whole range of workloads that people run historically in, you know, they buy servers to run these things, and DNS is one of them. And one by one, you see these workloads migrating into the cloud, either as, you know, VMs or into, you know, multi-platform, you know, multi-tenant, services like Azure DNS. And I think, you know, these things, especially where the scale of DNS is required, you know, they run much better as multi-tenant services, and that's why we thought that, you know, based on the feedback we had, that DNS is something that Azure should offer, and now it's something that Azure does offer. So, so I guess, I mean, thank you everyone for coming to the session and learning more about the service. Do sign up for the preview. All the instructions, if you just start at azure.com, you'll find everything you need. If there are any questions, I think we have a little time for questions. If there's any questions from the audience, and there's some microphones around. I don't know if you want to use the mics, or I can repeat the question for the people who are listening on Channel 9 or for the recording and so on. And the question was, do we support CNAMEs for @records? So we don't at the moment. You know, that's something that you know is a little bit of a grey area in the DNS the DNS world. At the moment, you know, CNAMEs, you know, they're not supported at the apex of the domain. Very happy to have a conversation, you know, about that and any needs there. Any other questions? I have one in the middle here. Thank you.
When you create a subscription for DNS, you need to provide a region. Why is that because it's DNS hosted?
Yes, very good question. So when in Azure Resource Manager, everything has a region. And most services in Azure are being regionalized or are regional. You know, when you create a VM, your VM is in a region. You know, so a lot of things are regional in Azure Resource Manager, and Azure Resource Manager itself is a regional service. Some things just are inherently global, and DNS is one of them. Traffic Manager that Vijay talked about is another. And in those, you know, because it's part of Azure Resource Manager, and the notion of a location is something that must be provided for all resources in Azure Resource Manager, therefore you have to provide a location. However, in the case of DNS and Traffic Manager, the only supported value is global. You know, so it's something that you specify as global, don't worry about it again. If you're in the tools like the PowerShell or the CLI, it does it for you. You don't even have to look at it. You know, it's a nature of Azure Resource Manager that a location is required. Good question, thank you. Very observant. One at the back there.
As a traffic manager, how granular can you get with the rules
Yes, you can do that. Yes, so in Traffic Manager, it has its own health probes for checking whether things are down, but on top of that, you can specify yourself whether a certain endpoint is enabled or disabled, and those two are kind of combined together to decide what are the actual endpoints that can be returned.
Load balance if, say, both data centers were up and we wanted to utilize both.
Yes, absolutely, yes. Yeah, and you can specify weights if you want to be, 60/40 or something like this. You have some flexibility there. One here.
Is there any plans to allow this? So we have DNS on premise. We want to forward to the Azure DNS servers.
So
Instead of like our ISP or any other.
So let me understand. Is this for hosting of authoritative DNS of internet facing?
Resolution of internet names for on premise. We're on premise. We would hit our local DNS. It would go out to the ISP DNS to resolve.
Okay.
Instead of using our ISP, could we use the Azure DNS?
So the question is whether Azure provides a service for recursive DNS resolution, if I understand the question correctly. Yeah. So when you run in Azure, we have a recursive infrastructure that's part of Azure that is available for all VMs and PaaS role instances running in Azure, and Vijay mentioned that. Microsoft does not today offer a public recursive DNS service, but there are a number that are available. Any other questions? One at the back.
Related to the Traffic Manager question, does it or Azure DNS support non-CNAME records?
So, okay. So thank you for the question. So just for the recording, the question was whether Azure Traffic Manager supports non-CNAME records. So today, Traffic Manager uses CNAMEs. So it provides an alias to the endpoint that you're referring to, something.cloudapp.net or whatever it happens to be. And some customers, they would like to avoid the CNAME because of the issue that the other gentleman mentioned regarding the apex of the domain. With the CNAME, according to the RFCs, for DNS, you can't have it at the apex domain. That means you can't have these naked domains, contoso.com without the W's when you use the CNAME, and that's something that we do here. Some customer Traffic Manager are keen to support. Today, Traffic Manager and Azure DNS are separate services, so the CNAME constraint is still there. It is something again that we're looking at, and something that we want to do is to bring these services closer together so that issue disappears. But that's something that we're as I say, there's a lot more investments that we're planning to make, and that's something that would be part of that. You're welcome. One more here.
Is there any plans to reduce the Traffic Manager Pro timeout? That's every 30 seconds.
Okay. Yes.
Failures a minute.
Yes. So the question with the Traffic Manager on the probes, where it's a fixed interval of 30 seconds on the Traffic Manager health probes right now. So yes, that again is something that we absolutely want to do. That's part of our Traffic Manager roadmap for, to make there's a number. I'd be interested in talking to you offline actually. There's the probe frequency is one setting. There's actually a bigger scenario there, which is really about saying how do we make endpoint failover faster. And that setting is one of many things that we could do in Traffic Manager to make endpoint failover faster and in a way more flexible as well. And I'd be interested in a conversation offline about the various other things that we're considering in that space that could light up the entire scenario rather than just adding one parameter for it. One more question over here.
Can you register records that are not from Azure DNS space? We use it for just true public DNS. We host with Rackspace, but you're the name server.
So the question was, can we host records that are outside of Azure AD? So yes. So Azure DNS is an internet-facing DNS service for authoritative domains. Right now, it is separate from the internal DNS that Vijay talked about, which would be the internal DNS for VM to VM lookups within Azure, and also separate from anything that you do with AD or so on, which again will be intranet-based. So it's an authoritative internet-facing DNS service. So you can host the domains in Azure that you're using with anything. I mean, whether the service is on Azure or not. I think Azure is a great place to host DNS for all the reasons we've talked about. Any more? They keep coming. One more here.
Yeah, sorry, I have a lot of questions.
No, that's good.
So, if we didn't have a very large Azure footprint and we were just looking to implement the Azure DNS, pretty much separate from everything else, that's something that can be done.
Go ahead. Yeah, absolutely. Yeah. So the question is, can you use Azure DNS without using Azure for anything else? And of course, we'd love you to use Azure for, for everything. But Azure is, it's a menu, right? There's a whole load of different services in Azure, and there's no constraint to say that you have to be using anything else in Azure to use Azure DNS. Obviously, we hope that you'll love your experience and you'll come back for more. Understand. Any more questions? There's one at the back here. So the question was, do we support DNSSEC? Not today. It's part of our roadmap. The design of Azure DNS has absolutely been done with DNSSEC in mind. There are things that we've done in what we've built that we would have done differently if we weren't thinking about DNSSEC, but we were. So it is something that we want to do. We recognize that the industry as a whole is moving in this direction. It's driven very much by some of the US federal government mandates around DNSSEC. So DNSSEC is a slow trend, but the trend is in one direction. And it's something that when we think about Azure DNS as a part of Azure, it's a strategic investment for us. It's a long-term investment for the Azure platform. DNSSEC has to be part of that story. So it's something that we want to do, as we build out the full, features, additional features over time. So the question was about whether we support IPv6. So there's two sides for that in DNS. One is whether you have Quad A records, which return IPv6 addresses, and the other is whether your name servers themselves you can make queries over IPv6. So today we have Quad A support, so you can set up Quad A records in Azure DNS. That works. Today, the name servers themselves are addressed via IPv4 only. That is something that we're looking at. Yusuf this morning in the talk on Azure networking made the point that Microsoft as a whole has made a lot of investments in the underlying network infrastructure to support IPv6, but there's more layers to build on top at the application level. So it is something we're looking at. It's worth bearing in mind for DNS. It's a slightly special case that you could have a service that is IPv6 only, and you can have a client, maybe a mobile phone or something, that is IPv6 only. And they can find each other and talk to each other just fine, even if your DNS is IPv4 only. Because the client is going to make a call to its local DNS service, its recursive service, and that may go over IPv6. That recursive service will have IPv4 support, and it can then look up the Quad A record for the IPv6 service using IPv4, and LDNS will always need IPv4 connectivity. So that link between IPv4 and Azure DNS can happen over IPv4. The Quad A record goes back to the client, and that makes the IPv6 connection to the service. So the end-to-end story can work with an IPv6 service and client, even if authoritative DNS is on IPv4. But having said that, we do like the idea that this should be a cleaner IPv6 end-to-end, and that is something that will come as we build IPv6 through the stack. A slightly long answer to what should be a yes/no question. Any more? Okay, one over here.
Are there any plans to make this couple a little bit more tightly with Azure VMs?
Very good question. So the question was about how we, the story about how we couple this with Azure VMs and with dynamic IPs. This is something that we're looking at. As we talk about Azure Resource Manager, and in particular Azure Resource Manager templates. Through templates, you have the ability to specify resources and specify, there's a lot of parameters for those resources. And those parameters can be specified explicitly. So if the resource is a DNS record, you can specify the IP address. Or they can be specified as references, where you say, okay, the IP address is, and then you reference a property of a different resource somewhere else, such as the IP address that's on a VM. And this would be using the new model for virtual machines and compute that was announced at Build. I don't know if you're aware. There's a new API. The Azure Resource Manager API is for networking and compute. So the way we would like this to work is via these references. Today, if the IP changes, we don't have the propagation to update the references. But the way we would like to do this, rather than having this thing that you have to manually set up some kind of alias or whatever, that you have those kind of, we see that we have a referencing story already in Azure Resource Manager templates, and what we want to do is to build on that to create the story there. Again, to address the scenario, through the templates. But it's not supported today, but that's the way this will go. Good question, though. Any more? Okay. We're good. Thank you very much, everybody, for coming.